Good morning, dear students. In yesterday period, we were discussed about Rutherford model of an atom and postulates of Rutherford model. It means electrons are embedded in the sphere of positive charge. The negative and positive charges are equal in magnitude. Therefore, the atom as a whole is electrically neutral. Third postulate, the mass of an atom is assumed to be uniformly distributed throughout the atom. Afterwards, limitations of Thomson's model of an atom. Finally, Rutherford's model of an atom and observations of Rutherford model of an atom and conclusion based on Rutherford experiment, and finally discussed limitations of Rutherford model of an atom. Yes, my dear students, today let us see Bohr's model of an atom. Already all of you know about Niels Bohr model of an atom. In a previous class, it means 8th standard already learned. So let us see. To overcome the objections raised against Rutherford's model of an atom, Niels Bohr put forward the following postulates about the model of an atom. Yes, first of all, the atom consists of positively charged nucleus around which electrons revolve in discrete orbit. That is, electron revolve in certain permissible orbit and not just in any orbit. Yes, my dear students, what here nucleus is positively charged. Nucleus is positively charged. Yes, as well as the electrons are revolve around a nucleus. It is the first postulate of Rutherford model. A second one, each of these orbits are associated with certain value of energy. Hence, these orbits are called energy cells or energy levels. As the energy of an orbit is fixed, it means stationary. Orbit is also called stationary state. Yes, my dear students, it means here K, L, M, N. They are termed as what? The orbits and also energy cells as well as energy levels. Yes, third postulate, starting from nucleus, energy levels, it means orbits are represented by numbers 1, 2, 3, 4, etc. by alphabets as well as K, L, M, N. Yes, my dear students, here K cell is termed as a first orbit, L cell is second, M cell is third and fourth one is N. Yes, my dear students, it means number of electrons are present here, how much? Okay, K is equal to 1, N is equal to 1, L, N is equal to 2, M, N is equal to 3, 4, N is equal to 4. Yes, it means how many number of electrons are present here. It is denoted as E1, it is E2, it is E3 and sorry. Yes, first cell is energy level 1, second cell is energy level 2, third is energy level 3 and fourth one is energy level 4. Yes, my dear students, and fourth postulates, the electrons present in first level, it means E1, have lowest energy. Energy increases on moving towards outer energy levels. Yes, my dear students, because the capacity of each energy level is, first one is K cell, K is equal to 1. Yes, according to formula, it means 2n square. Yes, 2 into bracket 1 bracket is to square, it is equal to how much? 2 into 1, 2. It means maximum number of electrons are present in case L is 2. Yes, second one is L. Yes, 2 into 2 bracket raised to square, it means 2 into 4, it is equal to 8. It means L, a number, maximum number of electrons are same, how much here? 8 electrons. And third one is M, or M cell or M orbit. Third one bracket raised to square, it is equal to 2 into 9, it means 18 electrons. Yes, my dear students, a maximum number of electrons present in an M cell is 18. Yes, and fourth one is N cell, N is equal to 4. Yes, 2 into 4 bracket raised to square, it means 2 into 16, it is equal to 32. N cell 32 electrons. N cell 32 electrons. Yes, my dear students, it means our energy level is increased. It means here lowest is termed as E1, okay, E1, and highest is termed as here E4. Yes, my dear students, it means total accumulation of electron or energy level is takes place from E1, E2, E3 and E4. Yes, fifth postulate is energy of an electron remains the same as long as it remains in discrete orbit and it does not radiate energy while revolving. Yes, my dear students, we people does not be seems what radiating energy when the process of revolving of electron is takes place. And last postulate of Bohr model is when energy is supplied to an electron, it can go to higher energy level, while an electron falls to lower energy level when it radiate energy. Yes, my dear students, what happened? Finally falls lower energy level when it radiate what energy. Yes, now let us see what are neutrons. Neutrons represented as small letter n. Neutron is another subatomic particle discovered by James Chadwick. Yes, discovered by James Chadwick. Yes, my dear students, who discovered neutron? James Chadwick in the year 1932. Yes, it is represented by, yes, neutron is represented by small letter n. It is represented by a small letter n. Neutrons are electrically neutral particle and are as heavy as protons. Yes, my dear students, they are termed as what? Electrically neutral. Electrically neutral. Yes, mass of neutron, mass is 1.674 into 10 raised to minus 27 kg. Yes, my dear students, first of all, discovered by neutrons are discovered by James Chadwick in the year of 1932, and neutrons are represented by a small letter n, and neutrons are termed as what? Electrically neutral, and mass of neutron is, yes, heavy as proton. It means mass is 1.67493 into 10 raised to 27 kg, which is equal to that of proton. My dear students, here neutrons are present in the nucleus of all atoms except hydrogen. The mass of an atom is given by the sum of masses of proton and neutrons present in the nucleus. Yes, we all are already know what the definition of atomic mass. Yes, it means The number of protons and neutrons are present in the nucleus of an atom is termed as what? Mass number. Yes, my dear students. Now, let us see distribution of electrons in different orbits. The distribution of electrons into different orbits of an atom was suggested by Bohr and Bury. For writing the number of electrons in different energy level or cells, some rules are as followed. Yes, my dear students, first one, the maximum number of electrons present in a cell is given by the formula 2n square, when n is termed as orbit number or energy level. Yes, my dear students, first rule is what? The maximum number of electrons present in a cell given by the formula 2n square. Yes, my dear students, here n is energy level or orbit. Clear? It means maximum numbers of different cells are as follows. Here first orbit, it means k according to formula 2n square 2. Yes, and second orbit L bracket raised to square, it is equal to 8, and third cell or third orbit M, it is equal to 18, and fourth orbit is N, it is equal to 2, 4 bracket raised to square, it is equal to 32 respectively. Yes, my dear students, it means the maximum number of electrons in K cell is 2. The maximum number of electrons in second orbit, it means L cell is 8. The maximum numbers of electrons in M cell is 18. The maximum number of electrons present in N cell is 32. Yes, my dear students. And second rule, the maximum number of electrons that can be accommodated in outermost orbit is 8. That is nothing but, my dear students, octet. Yes, what is given here? The maximum number of electrons that can be accommodated in the outermost orbit is how much? 8. Means formation of a octet configuration. Yes, third rule is Electrons are not accommodated in a given cell unless the inner cells are filled. Okay. Electrons are not accommodated. It means here, my dear students, only one electron is present in an K cell, that is not full. Okay. K cell is filled with the two electrons, that is termed as what? A duplet configuration. Yes, it means without filling what? A full capacity or full energy level of a cells or orbit, we does not be able to fill what? A second level or second next level of a orbit. Okay. Electrons are, third rule is, electrons are not accommodated, not accommodated in a given cell, in a given cell are filled, yes, my dear students. For best example, yes, examples are hydrogen, one S1, nucleus, K cell only one electron. Yes, second example, example number 2, helium, 1s2. It means two electrons are present, duplet. Third one is lithium. Okay, it means Li3, 1s2, 2s1. It means two electrons are filled in an K cell. Only one electron is seems where in an second cell, it means L cell. Take another one example, next example, fourth one, beryllium. For beryllium, Be4, 1s2, 2s2, K cell and L cell. Here in an K cell 2 electrons and L cell 2 electrons. Yes, in K cell 2 electron as well as in L cell 2 electrons. Fifth, boron, 5, 1s2, 2s2, 2p1, K cell, L cell. K cell accommodate 2 filled electrons and L cell only 3 electrons. And sixth one is carbon. C6, electronic configuration 1s2, 2s2, 2p2, nucleus, in an K cell 2 electrons and L cell 4 electrons, 1, 2, 3, 4. Yes, my dear students, here S and P, S, P, D and F are called orbitals, And seventh example, nitrogen, 1s2, 2s2, 2p3. Okay, it means K cell, L cell. K cell accommodate 2 electrons and L cell accommodate 5. 2, 3, 3, 4, 5. Take another one, last example, 8th one. Oxygen 8, 1s2, 2s2, 2p4. Yes, K cell and L cell. In an K cell 2 electrons and L cell 6, 1, 2, 3, 4, 5, 5 and 6. Yes, my dear students, see once again how the process of inserting electron is takes place here. Hydrogen, only in a K cell 1 electron is present. Yes, in an helium K cell 2 electrons are present. In lithium K cell 2 electrons, as well as in an L cell only 1 electron. Okay, take another example, nitrogen. Okay, here K cell how many electrons? 2, and L cell 5. Yes, in K cell 2 electrons, and in an L cell 1, 2, 3, 4, 5. Yes. Okay, oxygen 8, here K cell 2 electron and L cell 6 electrons. 1, 2 K cell, 1, 2, 3, 4, 5, 6 in an L cell. Yes, my dear students, in today's class we were discussed Bohr model of an atom. It means how energy level seems, and postulates concerned in Bohr model of an atom. Finally, who discovered neutron and how neutrons are represented, and neutrons are electrically neutral, and mass of neutron. Afterward, distribution of electrons in different orbits, and some rules are discussed here. Totally three rules are given by Bohr and Bury. And afterwards, distribution of electron, it means schematic atomic structure of first given some examples. Yes, thank you my dear students.